Now, going to discuss our next type, type 4. Type 4. What is this type 4 when we have to apply this? What is this type 4 and when we have to apply this? If q of x is equals to e power ax into v of x. If this is the case, then we have to apply type 4. What is this v of x here? Where v of x is equals to, it may be, for example, if I'm taking v of x is equals to e power bx, what is going to happen? What we can say? E power ax into e power bx form. What is that? E power ax into e power bx. How we can write e power ax into e power bx as bases are same, so we can add the powers. So what we can get it? ax plus bx from that taking x comma. So a plus b of x. Now you feel a plus b as some e, otherwise some l. Now it is in which form? For example, if I am treating this as e power lx. So now if this is the q of x, 1 by f of d of e power lx. What is the 1 by f of d of e power lx? In place of d, what we have to substitute? D is equals to a. In place of a, what we have here? L. And we have to continue with the type 1 only. Yes or no? Type 1 only we have to continue. But now, so because of that reason, I am not going to take e power bx. E power bx I am not going to take. I am not going to take e power bx. So if it is e power bx, you can easily say you can convert directly. But now v of x may be, what is the second case? Maybe sine bx or cos bx. What is the type 3? What is the type 3? X power m or x power m or a polynomial in functions of x variables. So I am taking p of x. If v of x may be any one of these 4, then we can apply type 4. Okay. So now, then q of x is equals, sorry, yp is equals to 1 by f of d of q of x, 1 by f of d of q of x, 1 by f of d of, what is q of x we have here? E power ax into v of x. If this is the case, what is the actual formula? You just hide this point. All of you, please hide this thing. How it looks like? 1 by f of d of e power x. Whenever 1 by f of d of e power x, what we have to substitute? Using type 1, substitute d is equals to a. But in this type 4, we have to substitute here. It is in the form of e power ax into v of x. So put d equals to a in type 1, but here we have to substitute d plus a. D equals to d plus a. This is important. Now, this we are substituting in place of e power ax into v of x is there. So then the role of e power x completes. Then it's going to become as 1 by f of d of, then the next step will be 1 by f of d of, simply v of x will get. But the role of e power x completed. So we must write e power x as the prefactor of this fraction. Is it clear to everyone? Is equals to e power x, we have to write it is as a prefactor. Whenever we are writing the e power x as the prefactor, then in the denominator in place of d, what we are substituting? D plus a. So this is the function. Now, for example, I'm treating it as just assuming it is like a e power x. Till completion of the problem, e power x we should write only as a prefactor. Even we should not write e power x in the numerator part also. in the numerator part. Like this also you should not write it. Okay, this is also wrong. Clear? Now, so 1 by e power ax into 1 by, now for example I am taking f of d is like this, d square plus 2d plus 1. In place of d, if I am substituting d plus 2, what is going to become? D plus 2 whole square plus 2 into d plus 2 plus 1. If we do the simplification, this again will be a function in terms of d variables, yes or no? So because of that reason, I am writing it is as g of d of v of x. Now, if v of x is equals to sine bx, if v of x equals to sine bx, now tell me it's in which type? It's going to which type? If v of x is sine bx or cos bx, then this brackets, last step, 1 by g of d of sine bx or cos bx, it belongs to which type? Type 2. From here onwards, continue with type 2. For example, this is not sine bx, not sine cos bx. It may be x power m or a polynomial in functions of x. Then it's going to be type 3. So from here onwards, we have to continue with our, as usual, regular types. Okay. So yp. So just for our understanding purpose, I am putting brackets like this. I'm putting like this, maybe in type 2 or type 3. Okay, this is the case. This is the procedure. Now I'm going to discuss problems on this. For example, first problem is it clear to everybody, the procedure? So this is the next problem is given. Solve d square minus 7d plus 6 of y is equals to e power 2x into 1 plus x. It is in the form of which type? Type 4. So we have to start our problem as usual. Given differential equation is d square minus 7d plus 6 of y is equals to e power 2x into 1 plus x. Take it as equation number 1. And what is the general solution? Then its general solution is y equals to yc plus yp is equation number 2. Finding yc. While finding yc, we have to consider auxiliary equation. Auxiliary equation f of m equals to 0 implies what is f of m is going to become m square minus 7m plus 6 is equals to 0. How we can write 7m as product of two values is 6 and their sum is 7. So how we can take it? Minus 6 minus 1. So m square minus 6m minus 1m plus 6 equals to 0. So minus 6 minus 1 is addition is minus 7 and their product is plus 6. So it is acceptable. Then taking m common from the first two terms, m minus 6, taking minus common from the next two terms, m minus 6 equals to 0. But now m minus 6 is common from both, then we'll get m minus 6 into m minus 1 is equals to 0. From this, we can conclude that m is equals to 1 and 6. The roots both are real roots. Both are real roots. So in that case, the complementary solution yc is equals to complementary solution or complementary integration or not integration, complementary integral or YC, all are same words. C1 into e power m1x, m1 value is 1, so simply x. C2 into e power m2x, m2 value is 6x. Equation number 3. Now you have to go for finding YP. Finding YP. While finding YP, we have to take YP is equals to, as usual, our procedure 1 by f of d of q of x. These are our basic formula. But here we have to take our f of d and q of x function. That implies YP is equals to 1 by d square minus 7d plus 6 of q of x. What is the q of x? E power 2x into 1 plus x. This is the given q of x function. Check it. E power 2x into 1 plus x. Now, according to our procedure, what we have to do? Anybody can say? Very, very important point is, for example, if we have here it is e power 2x plus in plus of 1 plus x. This is a type 1, this is a type 2, sorry, type 3. But here it is not plus, it is in product. In case of product, we have to go for type 4. What is the type 4? Substitute d is equals to d plus a. A value is in the exponential x coefficient. D equals to d plus 2. Yes, correct. This is important. It is in the form of type 4. Is it I am writing anywhere type 1, type 2, type 3, type 4, type 5 like this in the problems? No. Just by observing, calling it is as type 1, 2, 3, 4, 5 like that. Just for you need to remember. Now, the role of, okay, now if we substitute in place of dd plus 2, then we are going to get the denominator part will be d plus 2 whole square minus 7 into d plus 2 plus 6. This is only denominator part. And what about the numerator part? Post factor will be 1 plus x. And what about the pre-factor? Where we have to write e power 2x? The role of e power 2x completed. So because of that reason, we have to write e power 2x as pre-factor. This is important. If you are not writing e power 2x as a prefactor, and if you are writing it is in the form of a numerator e power 2x or as a post factor, if you are writing like this, this is wrong, this is also wrong. You should not write like that. Okay, now simplify the denominator part. Simplify the denominator part. E power 2x into 1 by a plus b whole square formula. A square, that is a d square, plus b square is 2 square is 4 plus 2ab. 2 into d into 2 is 4d. This is the first term of denominator. Minus 7d minus 7 2s are 14 plus 6. This everything is the denominator part of 1 plus x. Is the numerator post factor only. Okay. Now simplifying little bit more in the denominator. E power 2x into 1 by d square plus 4d minus 7d is a minus 3d. 4 minus 14. 4 minus 14 is minus 10. Minus 10 plus 6 is how much? Minus 4 of 1 plus x. Now observe this one, how it looks like. Observe these brackets, how it looks like. It is in the form of type 3. According to type 3, what we need to do? What we have to do? Write the denominator part in the form of 1 plus phi of x. For writing 1 plus phi of x, what we have to take common in the denominator? Just
minus 1 by 4 common.
No, minus 4 common in denominator. Minus 4 common in denominator. Just minus 4 common in denominator. Yes, what you said is also correct. Minus 1 by 4 common from the total fraction. But we should not say always like that. So now d square minus 3d by minus 4. Minus 4 already we have taken common, so plus 1 will be there. Plus 1 of 1 plus x. That implies minus 4 is bringing outside totally. Then it's going to become minus e power 2x by 4. Very careful while you are writing these other things. And taking this part to numerator. If I take this part to numerator, what is going to become? 1 minus d square minus 3d by 4. Denominator minus 4 is there. Now I have written this as plus 4. So that the coefficient is getting like this, of whole power minus 1 of 1 plus x. This one only we discussed. Now observe it. It is in the form of 1 minus x whole power minus 1. But what is the differentiation of 1 plus x? D of 1 plus x is simply 1. What is the d square value? 0. D cube value 0. That means up to first derivative only it is existing. So because of that reason, up to how many number of terms we have to expand? 1 plus x. Okay, I am writing this, whatever it is existing, yp equals to minus e power 2x by 4 is the first term, sorry, is the coefficient of starting the brackets with the braces. Yes, now tell me. So it is in the form of 1 minus x whole power minus 1. What is the expansion of 1 minus x whole power minus 1? 1 plus x. X is d square minus 3d by 4 plus x square. What is x square? D square plus 3d by 4 whole square. What, I have to take the next term or not? There is a d square minus 3d by 4 whole square. We have to take it or not? We should not take. Why? The reason is up to first derivative is only existing in the here. So whole power up to whole power 1 only we have to do it. Remaining all the terms you simply mention and so on. Even if we do that, it's a waste of time. We are going to get zeros only. That already we discussed. Now I'm going to write minus e power 2x by 4 into now what is the brackets is going to become 1 plus 1 by 4 into d square minus 3 by 4 into d plus and so on of 1 plus x. Now we have to multiply all the terms with 1 plus x. That means 1 plus x I am taking inside. Then it's going to become as minus e power 2x by 4 into what we'll get? First term is 1 plus x plus 1 by 4 into d square of 1 plus x is 0 minus 3 by 4 into d of x 1 plus x is 1. So all the remaining terms will be zeros. You can mention or not, no problem. Now finally, if we do the simplification of this, what we are going to get? Tell me. 1 plus x minus 3 by 4. So writing e power minus e power 2x by 4 into 1 plus x minus 3 by 4. So how we can write 1 as 4 by 4? 4 by 1 can be written as 4 by 4. 4 by 4 minus 3 by 4 is 1 by 4. So finally I am getting x plus 1 by 4 into minus e power 2x by 4. Put brackets for this. So this is our yp. After getting yp, what we need to do? Substitute equations 3 and 4 in equation number 2. Is there any difficulty? So yc plus yp, then yc is c1 e power x plus c2 e power 6x plus yp is minus 1 by 4 into x plus 1 by 4 into e power 2x. Why I have written this e power 2x as a post factor? Already you know that if we write e power to x as a prefactor, then you may feel x plus 1 by 4 as a the inside the exponential. So E is general solution of given D. It is a type 4. D cube minus 7d square plus 14d minus 8 of y equals to e power x into cos 2x. Now you people has to find out the roots and tell me fast. Fast, find out YC. Solution is given DE. Is d cube minus 7d square plus 14d minus 8 of y is equals to e power x into cos 2x. It is in the form of type 4. So taking it as equation number 1. What is its general solution? Y equals to yc plus yp is the general solution. Equation number 2. Finding yc. While finding yc, what we are going to get? Consider auxiliary equation. What is auxiliary equation? F of m equals to 0. What is f of m? In place of f of d, we have to substitute in place of dm. Then it will become as m cube minus 7m square plus 14m minus 8 equals to 0. Now we need to find the roots for this. For this, what I mentioned, use your calculator and find out the roots for this. M cube coefficient is a is 1, m square coefficient is b minus 7, and m coefficient is 14, it is c. In place of d, there is a constant term minus 8 we have to take. If we take that, then we are going to get
1, 2, 4 roots.
Okay, m is equals to good 1, 2, 4. All are real roots and are distinct, different roots. That implies, therefore, complementary solution yc is equals to, anybody can say what is a complementary solution? C1 into e power m1x, m1 value is 1, plus C2 into e power m2x, m2 value is 2x, C3 into e power m3x, m3 value is how much? 4x. Equation number 3. Now we have to go for finding yp. Finding yp. While finding yp, we have to take here yp is equals to, what is the basic formula? 1 by f of d of q of x. What is the q of x here is e power 2x into, sorry, e power x into cos 2x. So we have to take a this d function. Okay, let me copy. D cube minus 7d square plus 14d minus 8. This I am taking copy. Okay, is equals to, what we are going to get is equals to 1 by f of d is this of q of x. Q of x is e power x into cos 2x. E power x into cos 2x. Now, if we observe this, how it looks like? How it looks like? It is in the form of type 4. What is the type 4 procedure? E power ax into v of x form. E power ax into v of x form. V of x is cos 2x. So it is in the form of type 4. So put, according to the type 4, put d is equals to d plus a. What is the value of a? What is the value of a?
1, sir.
1. So substitute d equals to d plus 1 in denominator of this yp. That implies yp equals to 1 by d plus 1 whole cube minus 7 into d plus 1 whole square plus 14 into d plus 1 minus 8 of what is that? Cos 2x. But the role of e power x completed. So that e power x we have to write as a prefactor because there is no space here. So that I'm erasing, but you don't erase. You please make a sure that you must give some gap first for writing exponential function. So this is our problem. Now we have to simplify the denominator part. For simplifying the denominator part, I hope you understood. So now the next step will be e power x into 1 by, what is that? A plus b whole cube, a cube plus b cube plus a plus b whole cube plus 3a square b plus 3ab square. So this is the first term minus 7 into a plus b whole square, a square plus b square plus 2ab is 2d completed plus 14d plus 14 minus 8. This everything is denominator part. This 1 by of cos 2x. If you do, or if you want, you can use rough work. Rough work means last, not the last, somewhere else. You have to write it here only in the rough work. Okay, you have to do it, simplification, and do it. That is also one more step, one more way. But you don't do the rough work somewhere else in your exam paper. E power x into 1 by, I am doing directly. What is the d cube? Only one term is there, d cube. Now where is the d square terms? D square terms are here. It is 3d square. Here it is minus 7d square is minus 4d. So what we will get finally? Minus 4d square plus, what is the next term? I'm going to take d terms, 3d, okay, minus 7 into 2d is minus 14d plus 14d. 14d gets cancels. What is going to become finally? Plus 3d. Plus or minus, we'll see. Okay, now the terms which do not contain d, 1 plus 1 minus 7. Here it is minus 7 into 1 plus 1 minus 7 plus 14 minus 8. So what we'll get? 15 minus 15 is 0. So what we are going to get, the denominator part will be same whatever we have written till now of cos 2x. Now if we observe how it looks like inside the brackets, it looks like it is in the form of type 2. What is the type 2? Type 2, check it. Type 2, this is type 2. 1 by f of d of cos ax. It is in the form of type 2, not in type 3. Previous problem is in type 3, but now it is in type 2. Using type 2, what we have to substitute? Put d square equals to minus a square. What is a value? 2. In this step, a is 2. In the previous step, a is equals to 1. So be careful. D square is equals to minus 4, but we have d cube also. So on both sides multiply with the d, we'll get d cube equals to minus 4d. Minus 4d. So substituting these things here in the denominator, then we are going to get, it is as e power x into 1 by d cube. In place of d cube, I am substituting minus 4d plus, sorry, minus 4 into d square value is minus 4 plus 3d. This everything is denominator of cos 2x. Now, what is the denominator part is going to become minus 4d plus 3d becomes as minus d. So e power x into minus 4 into minus 4. Minus 4 into minus 4 is a 16. 16 minus d of cos 2x. Now, is it in the form of type 2? Yes. But what we can do? What we can do? Any idea? Any idea? Anybody? Rationalize. We have to substitute according to type 2. We have to substitute d square is equals to minus 2 square, nothing but minus 4. But there is no d square in the denominator, so that multiply and divide with 16 minus d. Then it's going to become as, 16 plus d. Multiply and divide with 16 plus d. Then it's going to become as e power x into numerator will be 16 plus d by a minus b into a plus b. It is in the form of a square minus b square is d square of cos 2x. Now, according to the type 2, what we have to substitute? D square is equals to minus a square. A value is 2. So put d square equals to minus 2 square is equals to minus 4. Then it's going to become as e power x into 1 by 16 square. What is the value of 16 square?
256.
256. 256 minus of minus 4. It will become 260 of that I'll separate it of 16 plus d of cos 2x. With this cos 2x I am taking inside part of these two terms. It's become as 16 cos 2x plus d of cos 2x. What's it's going to become? So now it's going to become as e power x by 260 into 16 cos 2x plus differentiation of cos x. What is the differentiation of cos x? Minus a sin x. Minus a sin x. A value is 2 here. So minus 2 sin 2x. So this is our yp. This is our yp. After getting yp, as usual, we know that substitute equations 3 and 4 in equation 2. Therefore, yc equals to c1 e power x plus c2 e power x plus c3 e power 4x plus yp. Yp is e power x by 260 into 16 cos 2x minus 2 sin 2x is the general solution of Q and D. Is general solution of Q and D. Our problem. Now check, this is our problem. D square plus 1 of y is equals to e power minus x plus x cube plus e power x into sin x. Now, starting the solution. So one of you please find it fastly. What is the complementary solution? Given differential equation is d square plus 1 of y is equals to e power minus x plus x cube plus e power x into sin x. It is equation number 1. Y equals to yc plus yp. Y equals to yc plus yp. So finding yc. For finding yc, what we need to consider? Okay, this is equation number 2. For finding yc, we need to consider auxiliary equation Consider auxiliary equation. What is auxiliary equation? F of m equals to 0. What is f of d? D square plus 1. F of m is m square plus 1. Then m square is equals to minus 1. Then minus 1 is nothing but I square. So m is equals to plus or minus I. When m, what are the roots of our equation, auxiliary equation? Complex roots. Therefore, what is a complementary solution or complementary integral? Yc is equals to e power ax. A value is 0. A plus or minus ib. Then e power ax into c1 cos bx plus c2 sin bx. So a value is 0. B value is 1. So we'll get finally c1 cos bx. Actually, we have to write like this. E power 0x into c1 cos bx, b value is 1, so c1 cos x plus c2 sin x. This is the thing. Equation number 3. So completed finding yc. While we are going to substitute this yc, then we will do like e power 0x we'll write as 1. E power 0x will write as 1. Okay. Now we are going to find yp. Finding yp. While finding yp, what we have to take? As usual, yp is equals to 1 by f of d of q of x. But what is q of x here? What is q of x here? Yp equals to 1 by f of d is d square plus 1. It's a very simple one. But what is q of x? E power minus x plus x cube plus e power x into, I think, sin x. We'll see. Okay. So e power minus x plus x cube plus e power x into sin x. Actually, you can do all the three things at a time, or you can convert it into 2 parts or 3 parts. But I am converting it into 2 parts. Part 1 is like this: 1 by d square plus 1 of e power minus x plus 1 by d square plus 1 of x cube plus 1 by d square plus 1 of e power x into sin x. Now I can take this as a type. Okay, part 3. Okay, this term is one step, and that term I am taking one step. But here I am substituting directly. Put d is equals to minus 1. Why? It's in the form of which type? Type 1. But what about the second term? In the form of type 3. This is in the form of type 4 and then type 2. So because of that reason, I'm just finishing it here itself. Put d is equals to how much we have to substitute according to type 1. D equals a. What's the value of a? Minus 1. If we substitute minus 1, what is going to become denominator value? 1 by minus 1 whole square is plus 1. 1 plus 1 is 2. 1 by 2 into e power minus x plus, I'm taking it as yp1 plus yp2. Taking it as equation number 4. Which one is equation 4? Yp. Is it, do we got yp1 and yp2? No, we need to find yp1 and yp2. Why I took like this? Because it may be a chance it will continue, or it will take a lot of space here. So that space is not sufficient for us there. Yp1 is equals to 1 by d square plus 1 of x cube. So how it looks like? Can I take the denominator part to numerator part? How it will become? 1 plus d square whole power how much? Minus 1 of x cube. Okay. Now what is the differentiation of x cube? 3x square. What's the differentiation of second differentiation of x cube? 6x. Third differentiation is 6. From the fourth derivative onwards, what's going to become? Anybody can respond?
0.
0. All the third derivative onwards, all the things become 0. So we have to take up to, what is that? Sorry, this is dq. I made a mistake here. Sorry, this is dq, this is d power 4, right? This is a d cube, d power 4, d power 5. Up to third derivative existing. So because of that reason, we have to take up to whole power 3. Okay, what is this 1 plus x whole power minus 1 form? What is the formula of 1 plus x whole power minus 1? 1 minus x is d square plus x square, d square whole square, minus x cube, d square whole cube, up to power 3 you take, plus and so on. One important point is, in the last class, last problems, type 3 we discussed, next terms become 0. It's not means that all the terms up to here non-zeros. There may be a chances zeros can happen. So if we do that, 1 minus d square plus d power 4 minus d power 6 plus and so on of x cube. So now, what is a multiply? Take this x cube to inside, then it will combine with all these terms. It will become x cube minus d square of x cube is simply 6x. What about the next term? 0. D power 6 of x cube is also 0, plus and so on. All the terms become 0. This is just yp1. So what is the final yp1 value we got? X cube minus 6x is just yp1. Now we have to go for yp2. yp2. What is the yp2? yp2 equals to 1 by d square plus 1 of e power x into sin x. Check, we have got the same. So this is only we have taken as yp2. Which one? This is the yp2, nothing but this term is the yp2. 1 by d square plus 1 of e power x into sin x. So when we take this one, what is going to happen is, now if we observe, it is in the form of type 4. Whenever it is in the form of type 4, according to our knowledge, we have to substitute d is equals to d plus a, which, what is the a value? 1 in denominator. Then the role of e power x completes. Then we have to write e power x as a prefactor of 1 by d plus 1 whole square plus 1. In place of d only we substituted it. Now if we do simplification, what is going to become? If we do simplification in the denominator, it's going to become as e power x into 1 by d plus 1 whole square, expansion a plus b whole square, a square plus b square plus 2ab plus 1 already is there. Now, according to our procedure, how it looks like, this brackets is in the form of type 2. In the type 2, what we have to substitute? Put d square is equals to minus a square. What is the value of a here? X coefficient inside the sine function. Okay, it is 1 square. So minus 1 we have to substitute. Here, in each and every step, wherever we are applying the formula, a may changes. A is equals to 1 in our previous step. Here d plus a is 1. Here also 1. That it may be same thing is there. For example, if we have e power 3x is there, then what we have to substitute? D square equals to minus 3 square, nothing but minus 9. So be careful, that is important. Now, if I am substituting this and also doing the simplification directly, 1 by d square is minus 1 plus 2d plus 1 of sin x. So denominator becomes as simply e power x into 1 by 2d plus 1 of sin x. But we are not having, it is in the form of type 2. We have to substitute d square is equals to minus a square form, but we are not having any d square in the denominator. So what we have to do, rationalize this. We have to multiply and divide with 2d minus 1. Then if we do like this, then e power x into 2d minus 1 of, okay, by 2d plus 1 into 2d minus 1. How we can write it? 2d whole square minus b square is 1 square of sin x. Now doing one more step, e power x into 2d minus 1 by 2 square d square, nothing but 4d square minus 1 of sin x. But according to type 2, we have to substitute, put d square is equals to minus a square, a value is 1, put d square equals to minus 1. Then we'll get e power x into 1 by 4 into minus 1 is minus 4, minus 1 is minus 5 finally, of 2d minus 1 into sin x. So 2 into d of sin x minus sin x. If we do the simplification, then almost we are going to get yp2 e minus e power x by 5 into 2 into differentiation of sin x is cos x minus sin x. This is our yp2. Brackets is very important here. Any mistakes from my side? Then you can respond. So substitute all these things in our equation number, what is that? 2. Substitute all these things in equation 2. Then y equals to yc plus yp. But yc is c1 cos x plus c2 sin x is yc. But what is yp? What is yp? 1 by 2 into e power minus x plus yp1 plus yp2. Check it. yc is 1 by, okay, sorry. yc is c1 cos x plus c2 sin x. Sir, what about e power 0x? E power 0x is nothing but 1. 1 into anything is that something only. So 1 by 2 into e power minus x plus yp1 plus yp2. yp1 is x cube minus 6x. That I'll write. Okay. So now final step. Y is equals to c1 cos x plus c2 sin x plus e power minus x whole by 2 plus yp1 is x cube minus 6x, x cube minus 6x plus yp2. yp2 is minus e power x by 5 into 2 cos x minus sin x. Hence, this is our required general solution of given DE. Okay, is general solution of given DE. So how many types we used in this problem? Type 1 we used, type 3 we used, and type 4 we used, type 2 also used. How many models we discussed till now? Type 1, 2, 3, 4. All the 4 models we used. Yes or no? That is important. So don't ask for this reason in mathematics which problem or which model is important. We cannot expect which question they are going to. Okay. Now here I'm going to explain the 6th problem. This is a given differential equation given DE. Now taking it as equation number 1, and how it looks like, it's a non-homogeneous linear differential equation. Then what is the general solution for this? Y equals to yc plus yp. I am giving direct steps, main points only. Now we need to find the complementary solution. For finding a complementary solution, what we have to consider? Auxiliary equation. What is auxiliary equation? F of m equals to 0. Consider auxiliary equation f of m equals to 0. What is f of m here? M square plus 1 equals to 0. Then what are the values of m? M square equals to minus 1. Minus 1 is nothing but I square. What are the values of m? Plus or minus I. Now, when we are getting a complex root, 0 plus or minus a plus or minus ib. What is the value of a? 0. So, what is the yc is going to become? E power 0x is 1 into c1 cos bx. What is the value of b? Imaginary part of this complex number is 1. So, c1 cos x plus c2 sin x. These are third equation. Now we need to find yp. For finding yp, what we need to take? 1 by f of t. Yp is equals to 1 by f of d of q of x. 1 by f of d of q of x. Now here the q of x is, okay, what is f of d here? It is d square plus 1. 1 by d square plus 1 of, what is q of x? Sine x into sine 2x, sine x into sine 2x plus e power x into x square. E power x into x square. Let me check. Yes, e power x into x square. Now, how we have to separate this? First, I am writing this as 1 by d square plus 1 of. Now, if you observe, okay, I am writing this is one term and this is another term. Like two terms, I am expanding. I am not taking like yp1, yp2. I am doing directly. Okay, sine x into sine 3x. Sorry, sine x into sine 2x plus 1 by d square plus 1 of e power x into x square. Now, if you observe the second term, how it looks like? What about the second term looks like? What we have to substitute? It is in the form of type 4, e power ax into v of x form. Okay, so substitute d is equals to d plus a. What is the value of a here? It is 1. Then I'm going to get like this, the second term. The role of e power x is completed, writing like this, e power x of 1 by d plus 1 whole square plus 1 of x square. Now, what is the first term is going to become? 1 by d square plus 1 of, how it looks like? Minus 2 sin a sin b. What is the formula of minus 2 sin a sin b? Cos of a plus b minus cos of a minus b. But here it is plus sin a sin b form. So it will become 1 by 2 of, okay, I am writing like this, 1 by 2 of sin of a plus b. What is the sin of a plus? Okay, sorry, not sin of a plus b. It is cos of a minus b. Okay, cos of a minus b. What is a value? X. Minus b value is 2x. X minus 2x is minus x. What is the cos of minus x value? Cos of plus x minus cos of a plus b. So we'll get cos of x plus 2x is a cos of 3x. Cos of 3x. Okay, this is the thing we are going to get. Now, separating the first term also like this as two terms. So what we'll get? 1 by 2 is common for both the terms of first and second. Okay, 1 by d square plus 1 of cos x is the first term minus 1 by d square plus 1 of cos 3x. Cos 3x plus e power x into 1 by What is expansion of d plus 1 whole square? D square plus 1 plus 2d. So I am writing d square plus 2d plus 1 is plus 2 of x square. Now, if we observe, the third term looks like which type? Now, okay, you can see here what we have to substitute. This one is looks like better. Okay, this one is looks like what? Type 2. In the type 2, what we have to substitute? If we substitute d square is equals to minus 1, what is going to become denominator? 0. Then is it we have to substitute here d equals to minus 1? No. What we have to substitute in the second term? Substitute d square is equals to minus 3 square, nothing but minus 9. Minus 9 plus 1 is 1 by minus 8. So you can substitute directly this one. Now, what we have to do in the third term? Any idea? So now what we have to do here, on the first term, if we substitute d square is equals to minus 1, that is using type 2, it's going to become 0. So that we should not substitute anything in the first term. So what we have to substitute in the second term? In the second term, we have to substitute, put d square is equals to minus 3 square is minus 9. And same manner here, we have to take we have to apply on the third term type 3 case. Okay, now 1 by 2 into differentiate the denominator part. Okay, I'm multiplying both the terms with 1 by 2. So 1 by 2 into differentiate the denominator part 2d, because we are substituting minus 1, then we'll get minus 1 plus 1 is 0 denominator. So the differentiating and multiplying the numerator with x as a prefactor. If cos x is the first term, minus 1 by 2 is the common for both the terms. Okay, 1 by 2 into 1 by d square is equals to minus 9, we have to substitute minus 9 plus 1 of cos 3x. So up to this first term expansion completed. Now on the second term, sorry, the last third term, e power x is there. We have to take the constant term common in the denominator. Okay, otherwise the least power of d. So 2 is the least, 2 into d power 0 is the least term which contains d. So d square plus 2d by 2 plus 1 of x square. If we do this type, okay, now first term is going to become as x by 4 into 1 by d, can be written as integration of cos x into dx, minus 1 by 2 into minus 9 plus 1 is minus 8, then it will become plus 1 by 16 cos 3x plus e power x by 2 into, then taking this part to numerator, then we'll get 1 plus d square plus 2d by 2 whole power minus 1 of x square. Then it's going to become as, the first term is going to become as integration of cos x is minus sin x. So minus x by 4 into sin x. Minus x by 4 into sin x is the first term, plus 1 by 16 into cos 3x is the second term, plus e power x by 2 into, now here it is in the form of 1 plus x whole power minus 1 of x square. So here, as we discussed earlier, differentiation of x square is 2x, double derivative, 2 times derivative of same function is 2, and the 3 times derivative is 0, and 4 times derivative is 0. We have to continue on the same manner. Okay, up to second derivative is existing, so up to power 2 we have to expand. 1 minus, it is 1 plus x whole power minus 1, 1 minus x d square plus 2d by 2 plus x square d square plus 2d by 2 whole square minus and so on of x square. Now I'm multiplying each and every term with x square. That is a last third expansion. I'll do it directly. So for the namesake, I'm writing 1 by 6 second term as the first one because of minus is a first term contains. So 1 by 16 into cos x minus x by 4 into sin x. It's completed. Plus e power x by 2 into, now 1 into x square is x square minus 1 by 2 into d square of x square is 2, okay, minus 2 by 2 gets cancelled, d of x square is 2x plus 1 by 4 into d power 4 becomes 0, okay, or d square whole square is 0, 2d whole square is nothing but 4d square, that is a 4, d square value is 2, d square of x square is 2, plus remaining term is d cube will get something like that, and so on. So finally 1 by 16 into cos x minus x by 4 into sin x plus e power x by 2 into, so highest power of x is x square, next is 2x. Now here it will become as 2 gets cancels, then we'll get minus 1 plus 2, here it is, minus 1 plus 2 becomes as minus 1 plus 2 becomes as plus 1. So this is our yp. Okay, now we have to substitute this equation number 3 and 4 in equation number 2. Therefore equation 2 implies y equals to yc plus yp. That implies y equals to yc is c1 cos x plus c2 sin x, c1 cos x plus c2 sin x, plus what is the yp? This everything is yp. So is the general solution of given differential equation. This one is the general solution of given differential equation. Is general solution. Hence, this is a solution.